In this video, we'd like to look at the examples from the review. So looking at number 1, a random sample of the number of bottles sold per day of raspberry iced tea is given in the following table: 22, 45, 46, 47, 48, 49, 52, 58, 65, 83. Compute the following. Show all work and only use calculator to check. Make sure to use the appropriate symbols. So first we want to look for the mean. Now notice that it specifies that this is a sample. Therefore we're going to use an X bar as our mean. For the mean, we want to add up all of our values and then divide by our total. So if we add up all of our values here, we should add up to 515. And if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we have 10 different values. So this is going to be my denominator. I take 515 divided by 10, and I get 51.5. Notice I'm leaving the 0.5. My data has whole numbers. Therefore, I want to round my mean to 1 decimal place, more than my data. Well, since my data has 0 decimals, my mean should have 1 decimal. So the mean number of bottles sold per day of raspberry iced tea is 51.5. Now we would like to look at the median. Recall, with the median, we must have our data arranged in order from smallest to largest first. Well, thankfully, this is already arranged in order for us. And then what we want to do is we want to look for the location. Since we want the median, that's halfway, and I'm going to multiply that by how many values I have, which is 10. Well, half of 10 is 5. Since I got a whole number, I need a little bit of buffer room. So I'm going to take location 5 and 6 and take their mean. So I'm going to go to 1, 2, 3, 4, 5, 6. I'm going to take these two values. So my median is going to be 48 plus 49 divided by 2. So the median is 48.5. I'm going to keep that decimal there because, again, my data has whole numbers, so I want to keep at least 1 decimal place here. So the median number of bottles sold per day of raspberry iced tea is 48.5. Again, the median number of bottles sold per day of raspberry iced tea is 48.5. Next, we want to look for the mode. The mode is the one that occurs more often than any other. Well, whenever I look at my data, every single one of these occurs the same number of times. Therefore, there is no mode on this particular case. No mode. Now I want to look for the variance. Recall, with the variance, the easiest way to do this is to set up your table with your values, then your value minus your mean, then your value minus your mean squared. So what I want you to do is I want you to go ahead and write down all of your values in this column, and then we will fill in the other columns. Okay, you'll notice that I've blown this up a little bit so it's easier for us to see. And what I've done is I've taken and written down each value in the first column. Then what I'm going to do is I'm going to subtract the mean from each one. Well, recall, in part A, we found that the mean was 51.5. So I'm going to take 22 minus 51.5, which will give me a negative 29.5. In my third column, I'm going to square that value. Negative 29.5 squared is going to give me 870.25. You will notice that I am not rounding in either one of these columns. We don't want to round until the very end again. So I'm going to continue this process. 45 minus 51.5 is going to be a negative 6.5. 6.5 squared will be 42.25. 46 minus 51.5 will be a negative 5.5. A negative 5.5 squared is going to give you 30.25. Now notice that this third column, everything is becoming positive. That's because whenever I take a negative times a negative, that's going to give me that positive. So everything in this third column needs to be positive. So now I'm going to go ahead and fill in the rest of this table. Pause the video so that you can do so, and then we will look at it. Okay, hopefully you were able to fill in the rest of the table. Again, taking 48 minus 51.5 and then squaring that value. And so we have this last column over here. The formula for variance, which is s squared because we're working with a sample, says to add up all of your values minus your means squared and then divide by n minus 1. Recall I'm dividing by n minus 1 because it is a sample. So what this is telling me to do is I've got to add up this last column, and again I don't want to round anywhere, so I get 2,198 and 50 hundredths. So I get 2,198.5. My n is how many values I have. Recall that we divided the value in the mean by 10. So I'm going to take 10 minus 1 here. And so we have 2,198.5 divided by 9. When we do this in the calculator, just to make sure that we get it correct, we get 244.277777778. Okay? Now our data has whole numbers, which means this needs to be rounded to one decimal place, which is 244.3. We need this number because in order to find the value that we actually use more often, we have to find the variance. Well, the value that we use the most is standard deviation. Standard deviation is the square root of our variance. So I'm going to take the square root of this value that we just found, 244.3. So the standard deviation is going to be 15.63009917. We want it rounded to one decimal place because our data is whole numbers. So our standard deviation is 15.6. And these are all the number of bottles sold per day of raspberry iced tea. Part F tells us to find Q1, Q2, Q3. So we're going to need that data in order, which you have at the top of your page. For Q1, recall that the location is 0.25 times n, which is 10 in this particular case. So 0.25 times 10 gives you 2.5. When we have a decimal for the location, we round that up to the next whole number. So we're going to look at location 3. So I'm going to scroll back up till we get to here. Here's 1, 2, 3. So 46 is my Q1. So Q1 is equal to 46. For Q2, well, recall that that's the median. Q2 is your median. So what was our median? Our median was 48.5. So Q2 is 48.5. Q3 is looking at 75% of the data, so we're going to take the location is equal to 0.75 times our 10. So our location is going to be 7.5. Well, since I don't have a 7.5 location, I'm going to look at the 8th location. So Q3, if I scroll back up, position 1, 2, 3, 4, 5, 6, 7, 8. So our Q3 is 58. So that's going to be 58. So recall again that Q2 is just our median. So if we found our median in part B, it's the same here as well. Now part G asks us to identify any outliers for the data set. So whenever we're finding outliers, we have to find what we call the lower boundary and the upper boundary. And anything outside of these boundaries are considered outliers. So the lower boundary says Q1 minus 1.5 times our IQR, which is Q3 minus Q2. I'm sorry, Q3 minus Q1. So I'm going to take Q1, which is 46, minus 1.5 times my Q3, which is 58, minus my Q1, which is 46. Be careful when you're doing this calculation. Make sure that you do the order of operations, which means to find what's inside the parentheses first. So 58 minus 46 gives me 12. Then we're going to do this multiplication. So we get 46 minus 1.5 times 12 gives you an 18. 46 minus 18 is going to give us a 28. Now hold on to that 28. Let's go ahead and find our upper boundary, and then we will look at our data. So our upper boundary is Q3 plus 1.5 times Q3 minus Q1. Now let's look at this, because notice this right here is the exact same as this over here. So whatever I subtracted here, I'm actually going to add it over here. So Q3 was 58. I'm going to add 18. Q3 plus 18 will give you a 76. So my lower boundary is 28. My upper boundary is 76. Now let's go back to our data set and see what this represents. So our values are already in order here. What I'm going to do is, my lower boundary was 28, which is somewhere between these two guys. My upper boundary was 76, which is somewhere between these two guys. If I box in that information, anything outside of that box is going to be an outlier. Therefore, this particular data set has two outliers, 22 and 83. So let's go back down here. There are two outliers, comma, 22 and 83. Those are our two outliers. These outliers are going to be important when we go to draw our box plot, which is part H. So I'm going to just draw a number line to start out with. And I really wish I could draw a straight line. My lowest value of my data set was 22. My highest value was 83. So if I start down here at 20, 30, 40, 50, 60, 70, 80, and 90, this covers the entire spectrum of my data. And I can go back in and add these halfway marks, which is going to mean 25, 35, 45, 55, 65, 75, and 85. For a box plot, recall that we draw a vertical line at our Q1. Our Q1 was 46, so I'm close to 46 there. We draw a vertical line at our Q2, which was 48.5, which is somewhere close to there. And we draw a vertical line at Q3, which was 58, so it's somewhere over here. And we box that in. This is the box part of it. Now I'm going to go back up to our data so that we can look at it. This right here, the red box, is what we consider the internal. The number just inside there, the 45 and the 65, are going to be where our whiskers go to. So scroll back here. We go to 45, and we draw a whisker. We go to 65, and we draw a whisker. Now I have not included the 22 and the 83, which were outliers. When we include those, they are included as asterisks. So there's 22, here's 83. Our outliers are considered asterisks. So let's look at the second example here. The students in Hugh Logan's math class took the Scholastic Aptitude Test. Their math scores are shown below. So we have their math scores. Compute the following. Show all your work. Now notice it says in Hugh Logan's math class. This is referring to the fact that it is a population. And so for the mean, we are actually going to use mu, because we're talking about the entire class. The formula for the mean doesn't change us any. It just tells us to add all these numbers up. We've got 10 numbers again. So we're going to add those up. And when we add those up, we get 4,504. We're going to divide by how many numbers there are, which there are 10. So when I divide this by 10, I get 450.4. Now I'm not going to round that because of the fact that my data has whole numbers. This has one decimal place. Okay? So the mean math score for the class is 450.4. Now let's find the median. This one's not put in order. So we got to put this in order first. So we're going to find our lowest number, 349. And then we're going to go to 350. So there's 349, there's 350. There's a 351. Not 551, 351. Let me try that again. So that's a 351. Then there's a 359. There is a 470. There's a 482. There's a 490. There's a 540. There's a 546. And there's a 567. So now that we have them all in order, our median, we're going to find the location. Let me change colors here because otherwise we're going to get things looking the same. So our location, median is halfway times our 10. So that is 5. It's a whole number, so I round up and take the 5th and the 6th. So 1, 2, 3, 4, 5, and 6. So the median is 470 plus 482 divided by 2. So the median will be 476. So the median math score for the class is 476. Part C asks us to find the mode. Nothing gets repeated, so there is no mode. Part D asks us to find the variance. So we're going to take our value minus our mean, and our value minus our mean squared. So go ahead and fill in the values here. You can fill them in any order. I'm probably just going to fill them in the order that they are written here. And let's see what we get. Okay, again, I have enlarged this a little bit. I've written in our values. And recall from part A, our mean was 450.4. So we're going to take 349 and subtract 540, we're going to subtract 450.4 from it, which gives me a negative 101.4. For the third column, we're going to square that value, which is going to give me 10,281.96. Notice I'm keeping all of my decimal places here. And so we want to do this all the way down. So we get a negative 100.4. We're going to square that. We get 10,080.16. And so I recommend that you pause the video and see if you can fill in the table for us. Okay, so hopefully when you were doing your calculations, we came out to have the same values. We're looking for the variance. Recall that this is a population, so we're going to find sigma squared. Sigma squared tells me to add up all the values minus their means squared. I'm going to divide by n. This one, since it's a population, I'm just dividing by n, not n minus 1. So I'm going to add up all these values, and when we do so, that gives us 72,310.4. Whatever we divided by for our mean is going to be the n that we put in here and divide by. So I'm going to divide by 10. And we get that sigma squared is 7,231.04. Our data has whole numbers, so we're going to round this to 1 decimal place. And I go ahead and put that 0 there. That signifies that I am doing some rounding. Okay? I'm not looking at just this whole number specifically. I have done some rounding. Now part E asks us to find the standard deviation. So that's going to be sigma. We're going to take the square root of that 7,231.0. And when we take that square root, we get 85.035, so forth. We want to round to 1 decimal place, so that's going to be 85.0. Okay, Q1, Q2, Q3. Q1, we're going to look for the location. I don't need an equal sign there, I actually need an arrow, because the location for Q1 is 0.25 times the number of values that we have, which in this case is 10. So that's going to give me 2.5. I'm going to round up to the 3rd position. So going back to where we have them in order, 1, 2, 3rd position, 351. Q1 is 351. Q2, recall, is our median. We found that in part B to be 476. Q3, we need to find the location, 0.75 times 10. That gives us 7.5, which we round up to 8. So I'm going to come back up here and look for the 8th position. So 1, 2, 3, 4, 5, 6, 7, 8. 540. Q3 is 540. I would like for you to see if you can find the lower boundaries and the upper boundaries for the data set, and then pause the video and then come back and check. Okay, so I have calculated the lower boundary. I took 351 minus 1.5 times my Q3, which is 540, minus my Q1, which is 351. I subtract these two values and get 189. Then I'm going to multiply that 189 by 1.5, and I get 283.5. I take 351 minus 283.5, and I get 67.5. That's my lower boundary. My upper boundary is going to be my Q3, which is 540, plus 1.5 times Q3 minus Q1. Well, remember that this value right here is the same as what we subtracted over here. So we actually get 540 plus 283.5, which is 823.5. So I'm going to go back up to our data set. My lower boundary was 67.5. Well, it's way down here. Okay. My upper boundary was 823. It's way up here. Notice if I draw my box in around here, I do not have any values outside of this box. That signifies that there are no outliers. So there are no outliers. Now we want to draw the box plot. So I'm going to zoom in a little bit. I'm going to draw, well, if I can get, there we go. I'm going to draw my number line, which again, it's not very straight. And I'm going to start with 300. And here's 400. There's 500. There's 600. Okay. So Q1 was at 351. So I'm going to go here. Here's 350, so here's 351. Q2, which was our median, was at 476. So it's going to be approximately here. Q3 was at 540, which is about right here. I'm going to box this in. Now my lower boundary was 67.5, and if I go back up, my first number inside that lower boundary is 349. So I'm going to draw a dot at 349 and draw a whisker to the box. My largest, or my upper boundary was 823.5, and since I do not have any outliers, my largest number, 567, which would be about right here, is going to have a whisker drawn to it. So I'd like for you to go back, practice these, maybe practice the next one, and then let me know if you have any questions.